Okay, so moving on to question 14. How would you define and explain periodic trends? So there are different types of periodic trends, but I'm just going to read out what the junior tutor said, just because it looks very well written. So periodic trends represents the order or degree of a certain property down a group or across a period. Periodic trends are useful in predicting the properties of a certain element. Some of the properties of elements with periodic trends are atomic radius, electronegativity, ionization energy, electron affinity, metallic character, and non-metallic character. Okay, so let's look at atomic radius first. So as you can expect, atomic radius is the radius of an atom. So let's say for sodium, there are 11 electrons. So I'm going to write out its diagram. And you can see that it has a valence electron, just one. So its atomic radius is the length of this blue line, pretty much. So basically, the more electrons you have in an element, the larger your atomic radius is. So our junior tutor says atomic radius decreases from left to right across a period. As you go across the period, the number of protons and electrons increase, I'm assuming. The electrons are pulled towards the nucleus, resulting in a smaller radius. So since the nucleus is positively charged, it attracts more of the electrons, so you get a smaller radius. Atomic radius increases from top to bottom within a group. As you go down the group, the electron shell increases, and electron shielding causes a larger radius. So that's like what I mentioned earlier. The more electrons you have in an element, the greater your atomic radius will be. So next, let's look at electronegativity. So it increases from left to right across a period since the electrons in the valence shell increases, which makes it easier to gain more electrons to complete its valence shell. Electronegativity decreases from top to bottom within a group. The increased distance between the nucleus and the valence shell results in a decrease in electronegativity. So the definition of electronegativity, if it wasn't clear from the answer, is the energy that is released when an electron is gained. So for example, let's say we have a chlorine atom that has 7 valence electrons in its shell. If it were to gain another electron, it would become Cl-. So since chlorine really wants to complete its octet, its electronegativity, when it gains an electron, is a very large number since a lot of energy is released and that reaction is favorable. So moving on, for ionization energy, this is pretty much the opposite of electronegativity, and it is the energy required to remove an electron. So our junior tutor said it is proportional to electronegativity. Ionization energy of the elements across a period generally increases from left to right as an effect of increasing valence shell stability. Ionization energy of the elements within a group generally decreases from top to bottom as an effect of electron shielding. Electron infinity increases from left to right across a period due to the decrease in atomic radius, and it also decreases from top to bottom within a group due to the increase in atomic radius. Metallic character decreases from left to right due to the decrease in atomic radius, thus atoms are less likely to lose an electron. Metallic characteristics increase down a group due to the increase in atomic radius, thus atoms are more likely to lose an electron. Lastly, non-metallic character is inversely proportional to the metallic characteristic trend. So here is just a figure showing all the different trends on the periodic table, and it just kind of summarizes what we just talked about. So I can verify that this solution is correct. Okay, so I think we have time